capacity of production from 2 and 3 inches OD to 20 inches. Okay, imagine the range is very wide of diameters. And we do that by using 13 accessories threading lathes. Those are basically CNC lathes, if you're familiar with them. Different manufacturers, from Japanese manufacturing to US manufacturing of the lathe itself. And our capacity is 40,000 ends per year. Okay. Then we have another facilities, one in Louisiana, other one in Bakersfield, California. When we have these facilities fully booked, fully operational, with all the shifts running, and we don't have more capacity, but the demand is higher, and then we license other third parties, which are these companies that they also through licenses they thread our connections, okay? Because we can do it in our facilities because it's full or the capacity is completely booked. Then a third party also do these connections for us. Okay, so we're gonna focus in McCarty. It's the facility where you guys are gonna develop this project. So I consider important you to know this topic here. Okay, so to give you a more picture of an accessory, this is a complete string that goes into the well, right? There are different type of devices and connections, and these are the shape of them. So, we have pop joint, we have crossover, and then later on we're gonna during the development of the project, you're gonna learn a little bit what is the function of each one. If you are more curious, we can go deeper into what the function of these devices or accessories are having into the string of the well. Okay, but just to give you a big picture, these are the type of parts that we thread in our facility, different shapes, different sizes, different materials, okay, coming from different manufacturers. That's we have a wide variation of accessories. Actually, the average size of the order right now is 4 pieces. So we can have order of 100 pieces of the same part, but sometimes we have order of only 1 piece. So because of the variation in application and shapes and sizes is very wide. Okay. So we have to be very efficient of the managing orders of 1 piece. Okay. Because some orders are really short, some orders are in the hundreds, but in average, I'm telling you, is about 4 pieces. Okay, and the delivery time is 4 to 5 days. Okay, it's very demanding. Okay, the delivery time for these parts. Okay, this is another example of nipples, crossover, pop joints, flow controls, packers. Again, some of these pieces we don't produce, we don't make them, but we put the connections in order for the customer to connect these devices to our pipes. So that's the reason they send us the part here so we can thread it for them. Okay. So this is more vocabulary for you guys to understand or because during the development of the project, you're gonna hear about talking about pop joint, plug, or flue, or flow collar. For you guys, it's kind of good get familiar with this vocabulary because every one of them has a different shape and a different function. Okay. So okay, now let's look into more reality pictures of what we're gonna be dealing with. Okay. So for tubular accessories longer than 15 feet long, this is how they look. Okay. You can see it's just a piece of pipe with length of more than 15 feet. Some of those we produce a lot of them, but some of them we receive from manufacturers. Like for example, number 7, you can see it's a very shiny piece, which means that it has a finish on the OD. Okay, so most of the time they come like with this finish, and we need to thread the ends, but without damaging or compromising the integrity of the part. Okay. Continue going with tubulars, less than 15 feet long. Okay, and we rate then in the this presentation is to kind of show a picture of how difficult for us is to handle the part, to move the part from process to process, from the resection all the way to the delivery. So for us, the rating of difficulty for this pipe of less than 15 long feet is 2, from 1 to 4. Okay. So again, this is basically shorter pieces, all tubular. Some of them with OD finish, some of them without OD finish. And for us, it's relatively easy to handle. But later on, I will explain what is the problem, okay? So I just wanted to have a picture of these parts. So as you can see from different sizes, 2 and 7A, 9 and 3A, OD, 9 inches, 13 inches, okay? More of these pictures, okay? Okay, now we enter into the OEM parts with OD work. OD work means that the part has been machined with certain finish center tolerances on the OD. Okay. Difficulty of handling is 3. So the more is a more complex piece. As you can see, they have different shapes, different sizes, different OD work. It's not just machine, but it has some additional work. Maybe it's a seal, metal to metal seal on the OD. And we, as probably the end of the supply chain of the manufacturing of this part, we need to be very careful on not damaging the part on the outside or on the inside, or any machining that the part already has. Okay. Because our role of functioning to the manufacturing of this piece is to put the connection, put the thread on it, okay? But then most likely the part will go to the well directly, or it may go to another shop where they're gonna do another machining. So, and these parts are really expensive. Some of them, the material is very expensive, so, and we don't have options to thread it wrong or damaging the part at the first time. So this is the rejection rate for this product. The allowed rejection rate is 0, so we cannot scrap the part, okay, or we cannot damage the part. That's for sure. Okay, more pictures of this part, okay, and I can share this presentation with you guys so you can have more time to look at it and to evaluate. As you can see, some machining or holes, things that personally I don't know the function of many of those, but what is important for us is to take care of the part and produce it properly. Okay. Other variation of the this part is which difficulty of handling is 4, is the most difficult part to handle, are these type of parts. Okay, some of them with very elaborated machining on the OD, like this, you know. These are most likely of these are mechanism in the well. Some of them have drill bits on it. For example, this part, if you can see number 4, at least 4.5 in this corner, it has 2 holes, right? And then we need to put the thread on one of the holes that is off center of the piece. So it's very difficult for us to set up the machine and make sure we don't hit the part or damage the part. Okay. Okay. I think this is more or less what I have for you on this part. So let's go back to the presentation. Okay. So as you saw all these different parts, The manufacturing flow for these ones start with the resection of the part. I put the OEM because that's the section of the product where we're going to focus on this project. Okay, we receive the part. Some of them we receive in pallets, some of them in crates, in boxes. Different ways or different packaging that we receive them from the manufacturer. Then we take that off the packing, and then we send it to the lathe to do the connection, to machine the thread. After that, some of those parts goes to an area that is called phosphatizing, the process that is called phosphatizing. Okay, it looks pretty simple because there are not too many processes, but I will explain you later what the problem is. So in order to move the part from station to station, we use forklift. You can see in the picture here, this is a lathe, and these are the parts that we need to machine. So we put this, we bring the parts to the machine in pallets. Okay, with the use of jig crane, we put it on tables, and then from the table we go to the machine. Some of those have special hooks, to lifting the special lifting devices, so we can safely handle the part and put it into the lathe. And some other comes with the axle horizontal. Some other comes like this with the axle in vertical. And we need to have a way to, because these parts are heavy, we cannot just flip it by hand. These are really heavy parts, and we are not fully prepared to handle these parts properly. Okay, without damaging or without having a risk of having an accident or an incident with the employees, having to pick up the part that is really heavy and cause an accident, to the person. Some of them are small parts that can be manual lifting, but some other times the guys are taking their chances and picking the pipe that is heavier than 50 pounds, and which is not allowed, because safety concern. So, okay, is everybody clear up to this moment, or any questions so far before going to the next step?
Class, some feedback for Mr. Hoyos.
Okay, so it looks like everybody's paying attention, so no question. Perfect. Okay, let's go to the problem definition. Okay. Okay, for a big problem that we have is due to the diverse shapes and sizes of accessories. We don't have a standard solution to handle those through the manufacturing flow. I would say the only standard thing that we have is a wooden pallet that we manage our way to put the piece on the pallet and then move with the forklift to each to each process. Okay, but again, we're having a lot of issues with that. Sometimes we're dropping the parts, sometimes we are damaging the piece, and it's causing a lot of problems with internal problems with safety and also with our clients. Okay, because sometimes they receive the part and they see that has been damaged, a dent, because the pipe hit with something during the handling. Okay, so damage are produced to the part during the handling process. Okay, like it can be damaged during the resection, during the transportation, during the threading process, or even during the inspection and packing, which is even worse. Once the part is ready and we spend a lot of hours threading the part, then we deliver the part to the inspection and packing area, and somehow the part get damaged. Okay, either because it stayed too long outside and then get corroded, or because the part gets fallen to the floor, or the part is hit by the forklift, by mistakes. So this is the main problem. Damaging the part that cannot be reprocessed, and we need to pay the part to the customer, because now the customer cannot use the part. Okay, and the type of damages most of the time are dents on the machine surface, or rust, or somebody paint by mistake on it, and also scratches. So this is what we're trying to avoid, to have dents or damages on the parts, okay? Because our poor way of handling these parts. Okay, that's the big challenge. Because again, the OD range is very wide. The shapes are very different between each other. So it's not gonna be one solution for all of them. It's something that I want to mention and make sure it's clear. And I'm really glad to have this team that is very, very diverse, as what I understand, uh, culturally, and also from specialists. Okay, I understand there are mechanical engineers, industrial engineers, I guess electrical engineer. I'm an electrical engineer, and I've been working in the maintenance department for almost 20 years. So, and I had to manage many mechanical problems in my experience. So I can also give ideas to you guys, things that had already thought that maybe you can put together and develop different solutions. Again, uh, out of this, many different solutions need to come, because it's not just one problem. Okay, so okay, so this is an example. I put this picture here of this part that that has been damaged. As you can see, the different machining or different work that has been done to this part. Okay, and then for the customer, this is very critical for them to have very good surface finish, and then we end up damaging the part during our process. So in these cases, we need to pay the part to the customer, and of course, the distrust of the customer in our processes. This is the most impacting part, when something like this happens. Okay, the same example where the finish of this product is 63, triangle 63, very critical. No damage can be made to this part. Okay, other examples. Okay, okay, cool. Now, very simple. The scope, as you may already, um, know, or maybe already, okay, I understand what the problem is. Basically, research different solutions to safely handle this wide range of sizes and shapes for accessories, of the accessories. Let's focus the scope into the OEM accessories, because it's the most critical, it's the most expensive part, and is, as you saw in the first presentation, is the most difficult parts to handle. They are difficulty 3 and 4. So this is I want to focus the scope on this group of accessories. Okay. Propose and design possible solutions to avoid damages during the handling and threading process, and propose a solution to improve the stacking and preparation stations. When we receive the part, we have an area where we're supposed to prepare the part, you know, um, to put it in the proper pallet to make sure the pipe will not fall or get damaged. But I see that is very poor, and it can be improved. Otherwise, we shouldn't have this type of problem. And I put the number 4. That is in, I'm not completely sure if we will have time to do that. but probably manufacture and test one prototype of one of the solution that it may come up from you guys. You know, try to prototype, test it on the floor, see if the operators like it. You know, because one thing is a technical solution, the other thing is the acceptance of that solution on the floor by the operators, and that actually have to deal with this every day. Okay, so this is what I have so far, just to give you a big picture of the situation, of the products that we do here, and also the scope of the project. So now I'm gonna leave the floor open to questions for any of you that may comment something. Okay, go ahead. Thank you.
Thank you, Oswald. So, class, if you have any questions to about the presentation, please go ahead.
Hi, my name is Kristen, and I have a question about the solutions that you want us to create, like a shape or maybe something that will hold the pipes in different areas. Will the shop floor areas have like different temperatures? Is that something we should maybe consider in designing it, or you know?
Okay, good. Yeah. No, we don't have a control, a temperature control areas for this manufacturing processes. I mean, well, let me rephrase that. For the process of handling, sorry, for the process of receiving, trading, also packaging, packing, and inspection, the temperature of the part of the process is ambient temperature. We don't have control areas, temperature control areas. The only thing that the part has to, and it's related to the part mostly, is when it goes to the phosphate, because the part is being submerged into a phosphate bath, which is at 110, no, 210 Fahrenheit. But that area, I didn't put any picture of that, but the pie is being picked or put in a basket and then is submerged into these tanks, okay? Completely submerged, or sometimes partially submerged into this bath at this temperature, okay? Yeah, for that area, we may need something different to handle the part. Yeah, if that was the question, I
Okay,
think
thank
for this area, we need to consider the temperature of the phosphate solution. Okay, thank you. Any other question?
I, I, I have a question. How technically inclined are the people that are using the machines? What should we, in terms of how complex the process would be?
Okay, good. We have different levels of, and is directly related to the job they do. For example, the trader or the late operator is very technical, very have a lot of knowledge. It's called premium operator, premium trader operator. It's one of the highest categories we have in our production team. Okay, they know a lot of CNC. They program the CNC. Very technical guys, very good guys. Now, the guy that drives the forklift, his background is very low regarding knowledge of technology. You know, the guys that is moving the parts into the phosphate area, he may not be the best technology um, knowledge guy. Okay, So that we have different profiles. We have very good guys that like technology, knows the technology, and some other guys that basically don't know because of the background. Okay, everyone in their area is doing their job, but I'm pretty sure that if we come with good solutions that will help them to do their job easy and safely, they're gonna be more than happy to adapt and to implement. Okay, because most of the time we try to implement solutions. Maybe we don't involve them in from the beginning, and then once we come up with the product and they say, okay, there you go, use it. They say, oh, well, what is this? Or, no, this doesn't work for this, or this doesn't work for that. So we cannot receive a reject, because people don't like changes, and I learned that from many years. They don't like change. They don't like changes. But a good approach will be to involve the guys. Come and talk to them and show them our ideas. We can have meeting with them on the floor. Maybe they can give us suggestion or solutions that we can include in our design. Okay, that's the approach that I will. Maybe I answer the question, or let
Yes,
me know. Okay, okay,
you
good,
did. Thank you. Appreciate it.
perfect. Okay.
I have another question too. You mentioned several places where the damages occur. Where do the damages occur most?
Where do you mean? What part of the piece, or in what
Like
part of the?
like what part of production? You said like reception and preparation, transportation, threading, inspection.
Okay, I would say in all different ones. Uh, but a critical one is on the lake, where the guys. Let me go back here. Maybe let me go back here. Okay, to this picture. Okay, for example, this piece right. Can you see the picture? This picture, left
Yeah.
button. Okay.
Yes.
So they use this jeep crane, right, to pick up this heavy part, right?
Mhm.
They pick it up with the crane, and they need to put this part inside this lathe. So these two gray doors, they open those doors, and they bring it in. Okay. Sometimes those guys hit the part against the chuck of the machine, and they dent the part. This is one of the damages that we have seen before. Or let's say they put the part, they thread it already, they finish the part on the lathe, and then in the process to put the part out of the lathe, and then they hit it with the chalk, and they hit it with the turret, and then cause a scratch or a dent. Okay,
Okay.
yeah. And other occasions that we had, other events that we have. For example, on this middle picture here, they pick it up with the crane, and they don't manage to handle the piece very good, and then they drop the piece to the floor, and now they damage the piece. Okay.
Okay.
Mhm. Okay. Perfect.
Thank you.
Is uh, is including, for example, the
Uh,
transportation or the focus on the...
Marcelo, sorry, I'm interrupting you. Could you repeat your question, please?
Okay, so are you hear me now? Yeah, okay. So my point is to clarify the definition of the handling process. So if this will include, for example, the transportation or just the manufacturing, as you told you in the picture, so we are close to the machine, or you are thinking in terms of the transportation after that or before that as well. So would you please clarify for us?
Okay. Yes. The includes the transportation inside the facility. For example, I don't have any picture here, but okay. We we receive the part. The part comes into the facility in trucks, okay? Flatbed trucks, small trucks, because the sizes. Okay, we take out the part from the truck with the forklift, okay? Most of the time, let's say, let's go here, because okay, there you go. For example, this picture shows a pallet with three different parts. Can you see that? Number the one on the top left.
Yes.
Okay. This part comes in a pallet. The person that make the part, or the company that made the part, they strap it with steel bands, okay? And they put a protection here, because they want this part of the piece to be protected. What happened? When we take it out of the truck and we put it in our shop floor, the first thing they do, they cut the bands and they remove the wrapping and basically put it in a pallet like this. Why is that? Because maybe they can split the order and send these three different parts to three different machines. Okay? Now the forklift operator need to move this part like this, like something like this, to a machine without any strapping, without any protection. And in this process, the part can get damaged. And we had situations like that. So the transportation is part of the problem. If that's your question.
Yes.
Okay,
Okay. Thank you.
perfect.
Any other questions? Um, I have a question for Mr. Hoyos. Eventually, when the students get into the problem, they will maybe have some questions, and maybe they would want to talk with the users of the solution that they will be providing. Is that opportunity going to be available? So at some point, when they have already thought about this a little bit more, would it be possible to arrange maybe some either visit or even conference calls like this with some of your equipment, some of the users of or those that are experiencing the problems?
Yes, Jorge. Yeah, we are open. We are open our first. We are open our doors for you guys to come by, to visit the facility, to see the problem happening, on live, and also to conference. Okay, we can set up schedule the conference or the visit with enough time, so we are prepared for you. We schedule our time for you guys. Separate, I don't know, one afternoon. I'll be happy to receive you guys. Many, probably not all of you may be able to come, especially the guys that are in Brazil. Very hard for them to come. But yes, totally. Actually, I encourage these teams to come over and look at the facility and visit us. This is always a plus and I encourage the guys to do that. I have some ideas that I want to share with you guys, not today but later, to show you how some other people manage these parts, because we are not alone in this problem. Some other companies have a better installation or better ways to handle these parts or to manage this part, because this part is made by a manufacturer and they are not damaging the part. So why are they doing? We can. I have some some pictures of other facilities that they implemented some actions in order to avoid this problem. I can share those with you, so you can either think about those and add, whatever you consider necessary to improve the situation. Yeah.
Okay, great. So also, I have recorded this conference, Oswald. Is it okay if I post it for the students to view, especially those that were not able to see it? So this particular presentation, you say that you will be sending me the actual PowerPoint presentation, correct? And is it okay that I share this particular meeting just with the people in the class? So would that be okay with you? Oswald?
Sorry, I had the microphone mute. Yes, no problem. Yeah, yes.
Okay.
Go ahead. Yeah, no problem. Yeah, you can share it with the team, especially the ones that couldn't make it, so they can catch up to speed.
All right.
And I will send this as soon as we finish the conference, the presentation, the 2 PowerPoints. I will send you the link of the video, so you can see again. Okay.
Excellent. So, if last chance for maybe a last question from the class. If not, then we should be already okay to adjourn. Anyone? Any questions? Okay. So, Mr. Royos, thank you so much. We will be looking into this. I will be assigning the project to some teams, and I am sure that after that they will be thinking about the problem and having many questions and maybe requesting for more clarifications of trying to scope a little better their project. I will ask them to probably, those that are assigned with the project, to write in their words what is what's the problem they understand, and we'll send that to you and see if you agree with the problem statement they propose.
Okay, good. One question. The next step will be then to discuss this possible solution or the questions and answer session. What do you think will be the next step, and when do you think this will happen?
I think I will ask the teams to think about the problem, look into what other people are doing in terms of this type of problems. Maybe they'll prefer to focus in some particular stage of your process. You've already said where do you see most problems, and once that happens, maybe that's a week from now. They will probably come back to ask you more specific questions. So for you, you have maybe 1 week that is you're not going to hear from us too much.
Okay, yeah, that's what I was thinking. Okay, good. Perfect.
Very good. So thank you, Mr. Royos, and for the class, please be waiting for an email from me. I will be asking very specific questions, and I will be waiting for an answer from you no later than tomorrow. So please be attentive. You will be getting some requests in terms of this project and the previous project as well. Okay? Anything? Brazil, thank you very much for joining us.
Okay. Thank you. Bye-bye. Bye-bye.
Bye. Bye, Oswald. I'll see you next time. Thank you very much.